Hi, I am Mrs. Sloan, and this is a video for my AP Biology students. And I'm going to make myself a little bit smaller. If you are new to my videos, then let me tell you, sorry, I'm getting in presentation mode. Let me tell you that down in the descriptor below are where there's a link to my students' notes that they use. It's 2-column notes. Column 1 is scaffolding. I'll help you fill that in. And column 2, I encourage my students to put pictures in there. And also there's a link to this presentation you're looking at right here, if that would be helpful for you. All right, so this chapter is chapter 46 for us this year, and this is major ecosystems of the biosphere. A better name might be, because biology is the study of life, is why does life live where it lives? That's really what this chapter is about, and that's what we're going to focus on as we discuss it. So I want to remind you, I have unit guides to go along. We are in Unit 8, Ecology, the final unit of the year. And the topics of this chapter will be 8.2, energy flow through ecosystems, and 8.7, disruptions to ecosystems, because in this chapter, we're going to set up the importance of different items within our different ecosystems to see how man can screw them up later. So we'll come back to some of these topics a little bit later. So on 8.2, I would point to these two enduring understandings, explain how changes in the energy availability affect populations and ecosystems, and you can read through that, and explain how the activities of autotrophs and heterotrophs enable the flow of energy within an ecosystem. So I encourage you to pause that and read through that so you know what expectations. And then I pulled out a few more on describing the relationships between ecosystem diversity and its resilience to changes in the environment. That's from 8.6. And 8.7 down here, explain how geological and meteorological activity leads to the changes in ecosystem structure and or dynamics. So this chapter really has its fingers in several different expectations. So the big ticket, I'm trying to move myself. Okay, maybe. Okay. Okay, sorry about that. Let me go back. Boy, the struggle was real there. The big ticket items that I need you to know from this chapter is, how does the availability of resources affect an ecosystem, like light, moisture, and nutrients? And then keep in mind that species abundance and diversity, that's all going to be dependent on primary productivity. Primary productivity in a nutshell is just how much photosynthesis is that area doing, right? How many sugars, how much oxygen is it generating? So areas of the planet with more light, warmth, maybe along the equator, light, warmth, longer growing seasons will have greater productivity and therefore greater diversity. And then always keep in mind, we want to understand these ecosystems and these biomes so that we know on the choices that we make how it might influence the life that is there. All right, so first thing you want to differentiate between is weather versus climate. So weather is the temperature right now, the conditions in the atmosphere at a specific time in a specific place. Climate is looking at temperature and precipitation over time, over decades. And this is determined mostly by unequal amounts of solar radiation that different areas receive. So on your notes, we're at 46.1, climate in the biosphere. Climate is dictated by temperature and rainfall. That's what you need to have in your notes, temperature and rainfall. And then I gave you the rest. This is going to be influenced by solar radiation, topography, wind, and whether a body of water is nearby. And I'm going to go over all of that with you. When we talk about climate, there's your macroclimate versus your microclimate. So your macroclimate is the climate of an overall region, maybe Central California. A mesoclimate is the local climate, let's say, of a vineyard in that area, but a microclimate is the climate specific to an individual plot within that vineyard. The difference in the shade of a leaf as opposed to the direct sunshine. So those are microclimates. So macroclimate patterns work at global, regional, or local level. A microclimate, got some notes there, determined by fine scale variations such as sunlight and temperature under a log or under a grape leaf. Okay, determined by fine scale variations such as sunlight and temperature under a log. Now, what's happening to climate overall? Well, are we experiencing some climate change? Yes, we are. And man can change things rapidly, right? We could take down a forest in one day, just cut it down, and we're going to change the climate like that. And obviously the species that are living there aren't going to have time to adapt to that. So we'll watch this video in class about how fast we are changing the climate. And you can look at different forests. Canada's boreal forest, where if you think of a coniferous forest, the taiga is the colder part of it connected to the tundra, where the boreal forest is the southern part of a coniferous forest, maybe closer to a temperate deciduous forest. And this is a link you can follow if you want to download this presentation to see how that impact is. And we're going to study that more in later chapters. But right now, what I want you to have for your notes is increasing greenhouse gas concentrations in the air are warming the earth and altering the distributions of many species. Some species will not be able to shift their ranges quickly enough to survive. So let's look at one of the major impacts on climate, and that's the amount of solar radiation. So you have the earth, right? And it's a sphere and it's on a tilt. Okay, so both of those are going to be important. So when you look at this region right here, okay, at the equator, and you look at the amount of light, you can look, this amount of light is affecting this region, right? The same amount of light as the earth curves, right, affects a larger region. So that means you have less radiation, less heat in those regions. And what is that tied to? Primary productivity, right? So you're going to have less primary productivity at the poles than you will at the equator. So on your notes, because the earth is a sphere, energy from the sun, this for your notes, energy from the sun is spread out over larger areas near the poles. Energy from the sun is spread out over a larger area near the poles. So you have less solar radiation, less photosynthesis, right? And that's going to be tied to species diversity. Now, on top of that, okay, our Earth is a sphere, but it is also tilted. And so because the Earth is a tilt, we have different seasons in the northern and southern hemispheres, Now, I'm going to go on a little topic briefly about wind, okay, because wind is going to affect the currents, and currents, there's a lot of things that impact currents, but temperature is going to affect this as well. So we just need a little understanding about wind. So the first thing I need you to know is when hot air, when it gets hot, it's going to rise, right? It's going to evaporate. And if it's got moisture in it, if it's got moisture in there, then that moisture, as this air rises, it will cool off. It could drop that moisture and cause rain. So remember, climate is dictated by temperature, rainfall, and topography. So you're going to get rain. Now, let's talk about high pressure and low pressure. So where it evaporates, that's a low pressure system. As it cools and sinks, this creates a high pressure situation. In high pressure situations, you have clear skies, right? And in low pressure situations, this is where you have that moisture. And where two fronts come in contact with each other, then you can have a disturbance, right? You can have these different storms. But we just need to get in mind, hot temperatures rise, cool, sink, right? And they lose their moisture, right, as they cool off. So I think I gave you everything for that. So let's make the connection to wind. Air is going to take on the temperature of the water below it, right? So if the water is warm, then that temperature is going to increase in the air and it's going to cause it to rise. So that warm air moves away from the equator in a clockwise direction in the northern hemisphere and in a counterclockwise direction in the southern hemisphere. And then these winds moving across the water, these are going to create currents. So why are currents a big deal, right? Because currents are distributing nutrients, they're distributing oxygen, right? And so that is going to make the resources available for those organisms in those waters. And this helps with our whole global climate as well. So the ocean currents regulate our global climate. So you can see, and we'll watch a little, wherever you see this, me eating popcorn, that means there's a video link you can click on. But here you can see, here at the equator, right? It's hottest. So you have this low pressure situation, air is going to rise, it's going to cool, and it's going to sink and create a high pressure situation. And it goes, these winds are going in the clockwise direction in the northern and counterclockwise in the southern, which then dictates those currents as well. And that dictates nutrients. So I gave you also, yeah, we're good. We're still good on the notes. I gave you all of that. So then let's talk about disruptions to that, things like El Nino. So here's your normal year, okay? And keep in mind that the amount of water we have on this planet is finite. So if you change the amount of rain in one area, if one area gets more rainfall, some other area is going to get what? Less rainfall. Good. So El Nino is an interesting, there's lots of dynamics with El Nino, but basically you have warmer waters and you have a combination of those warmer waters with less easterly winds. And as a result, then water falls in a location it doesn't normally fall in. And so an area can get a huge dump of water, which it may not be ready for, right? And another area is going to have less water. So that is El Nino. So topography can also affect waterfall. Remember, climate, temperature, rainfall, and topography. So when you have winds coming over across the oceans, they're going to pick up moisture, right? And then if you hit a mountain, then this is a physical structure, maybe not due to heat, but due to a physical structure, that air is going to rise. When it rises, it cools and it drops its moisture. So on the windward side of a mountain range, you're going to get the type of species that if you need a lot of rainfall, for instance, trees need a lot of rain. And so you're going to get those trees here on the windward side, but in the rain shadow, the area that's not they're getting this dry air, then you're not going to have those trees because they don't have the rainfall, and you can have a desert situation. So when you look, on your notes, other effects, topography, physical features of the land, as air rises due to mountain features, moisture is dropped on the windward side. On the leeward side of the mountains, the now cool air sinks and the area is in the rain shadow. Now we see this here in California with the Sierras. So if you look right here, here's Yosemite, and here you can see the greenness because as that moist air hits the mountains, it drops the rain. But then here on the eastern side of the Sierras, like Bishop, then creates these desert conditions. All right. Now, air is, if you look, let's see, onshore and offshore breezes, if you're familiar with that. So the land can only hold so much heat. And so when it can't hold any more heat, it radiates it out, which then heats up the air. So then the air rises. So you then get this air rising and it gets replaced by cooler air, and you get those onshore breezes as they're replacing the air that is evaporating, and this is what you will get. But in the evening, when the air is cooler, you will get the reverse, because what happens is oceans will gain and lose heat more slowly, because remember, water molecules in the ocean, right? Remember those bonds, those hydrogen bonds? And so they can hold that energy. And so it's like when the sun shines on it, it's like, I can take it. And it gets distributed, that energy, amongst the water molecules. So it can take a little more heat than the land can. So it heats more slowly, and then it releases that heat. As the evening cools, that energy is going to leave the water, and then it causes this air to rise, and then it is replaced. And that's why you get an offshore breeze in the evening. So on number 2, air heats up and rises more rapidly over land than water. Water holds more of the energy in its hydrogen bonds. Morning, you have an onshore or onward. Land heats up, air above the land rises due to heat, replaced by air over the ocean. So you have an onshore breeze. And then you have everything there in your notes for the offshore for the evening. All right, so then let's apply that to what's going on during a monsoon, right? So if you're in India surrounded by water, if this land is heating up, right, at certain seasons more so than others, then as it heats up, the air rises and the moist air is coming off the water to fill in the air that rises. And then that's why you get all of those rains. So on monsoon, you have everything there. Okay, then let's also talk about the lake effect. So when you have winds going across lakes, they're picking up moisture. And then as they move over and across land and start to warm up, they're going to drop that moisture as snow. And so you can see the direction of the winds by the snow pattern that falls. All of these things, right, are going to affect the life in that area. And that's what we need to keep remembering. So the lake effect, winds pick up moisture over a lake and then drop that as snow once the air starts to rise over the land masses. Okay, so with that setup, then we can start talking about biomes. Biomes on our ecosystems that have similar climax communities, either flora or fauna, right? So they'll have the same types of plants because of similar temperature and rainfall. So you can have terrestrial, land biomes, or aquatic biomes. Guess what we have more of? Aquatic, right? Because or more of our earth is dedicated to the aquatic biome because it's mostly water, right? So here we can dictate on our biomes on land. If we know the temperature and if we know the rainfall, we can dictate what kind of plants could live there and the animals that could live there with those plants, right? So on our introduction to biomes, the terrestrial biomes are characterized by climate, temperature and rainfall, and geography. Climate and rainfall. Climate and geography. And B, it contains plants and animals that are adapted to living within a specific range of environmental conditions. Animals can migrate to different biomes throughout their life cycle. And a climograph is what you're looking at right now. You can plot biomes according to their mean temperature and rainfall. Now, you can see, well, let me go over this first. So let's take a look. Here's rainfall, here's temperature. So let's go where there is low rainfall, very low rainfall. If the temperature is high with low rainfall, what do you have? You have a desert. Now let's look at the other extreme. If the temperature is cold and you have low rainfall, then you have tundra. Okay. And then the other thing I want you to note is look at rainfall. And as you work from left to right, you see trees start coming up, right? Because trees are going to need that moisture. So if you look at, for instance, this warm grassland, how did you move from a desert to a grassland? You're the same temperature. What has changed? Rainfall allowed you to have grasses. When you move from this warm grassland to a savanna, what's the only thing that has changed? The temperature is the same. It's the amount of rainfall, which has allowed you to introduce more of these types of trees. And then you have your tropical deciduous forest and then your tropical rainforest, all dependent on that rainfall. Okay. Now, another issue is the type of tree you're going to have based on the temperature, right? Here in a coniferous forest, when you have rainfall, you're going to have snow, and those snow could break those branches. That's why you see those leaves that have needle-like leaves. And that's typical of a coniferous forest, where you have more broad leaves taking advantage of all that direct sunlight here in the tropical rainforest. So you just can look at temperature and rainfall, and you can predict the biomes. You can also, another cool, let me show you this picture first. So here you can see tropical forest. Look right here along the along the equator. There we go. I couldn't think. All right. And then as we move, I want you to see, look at these deserts. Why are these deserts right next to these beautiful tropical areas? Well, think about it. As the air rises due to the heat, it's going to drop its rainfall, and that's going to provide you have these wonderful lush vegetation. But then when it falls, it's not going to have any moisture, and it's going to be very dry. And we know when you have dry air that's where you're going to have those deserts. And then you can see this alternating depending on the flow of the air and your high and low pressure conditions in the wind. And topography too, where you have those mountains, right? So look up here in the Western United States, you can see that you have these moist areas along the coast, and then you can follow it right up with a desert because it's dropped all of its moisture as it hits mountains. All right, now you can also take a look here, and you can plot them based on where, if you increase in altitude, if you go towards up in elevation and increasing in latitude, you'll go through the same patterns. So look right here. Here's your tropical rainforest. That would be like your latitude 0, right? But as you increase your latitude, you're moving towards the poles. So you go from your tropical forest to your temperate deciduous forest, your coniferous forest, Arctic tundra, and ice, right? So now you're at the poles. But you can go through that same experience if you just go up in altitude. Why? You're going to have less rainfall and it's going to get colder. So that's the next part in your notes where it says, climate graph, see similar pattern comparing an increase in latitude as you would with an increase in altitude, All right, now let's transition to an overview of aquatic biomes. So aquatic biomes make up the largest part of the biosphere, right? That's where life exists, because water covers roughly 75% of the Earth's surface. And this is where you have most primary productivity. Now, you can classify your aquatic biomes as either freshwater, these would be like inland bodies of water like lakes, saltwater, which would be marine, and brackish, where you have a mixture of both, like an estuary. So on your notes, the only part you need is freshwater, lakes and wetlands, or moving bodies of water as in streams or rivers. And then when you look at the water cycle, forgot about this. So marine ecosystems impact the planet by producing over 50% of the plant's oxygen and providing the majority of precipitation as water evaporates from the oceans. So when you look at the water cycle, right, when this water, most of the water is going to be coming off the ocean, but eventually you're going to have precipitation and rain, and it's going to work its way back through lakes, rivers, and streams and back to the ocean again. So in the water cycle, eventually all fresh water will be returned to the sea, okay, though along many different routes. So also when you look at bodies of water, okay, you have different zones. So you have photic zone, which think photosynthesis, where you have light, and aphotic zones where you don't have light. If you don't have light, then you're not going to have photoautotrophs. Now, could you have chemoautotrophs from a hydrothermal vent? Sure, but you're not going to have those phototrophs here, okay, in these aphotic zones. Also, look when you're onshore, moving off, so you're going to have more plants that are anchored in the soil here, right, along the coast, and then as you move out into the open ocean, you're going to have things like phytoplankton and zooplankton. So on your notes, most display vertical stratification, and then I gave you photic and aphotic zones. All right, and then that's going to take us to terrestrial ecosystems, and I'm going to go walk you through these different ecosystems, and we're going to look for patterns in climate and flora and fauna, but I'm going to do that in video 2.